Let's solve question 4 in this video. Let's go through part A and B, and then we'll leave part C for the next video. So in question 4a, we have a function f of x equals to e to the power 2x, and we want to find out the inverse. So we want to write x in terms of y. Well, remember that f of x is the same as y. So if this is y, and we write that y equals to e to the power of 2x, alright, how can we have only x on one side? Well, we would like to get rid of this e. So how do we deal with it? We take the logarithms of both sides. So if we take ln here and ln on this side, what are we left with? Ln of y equals to ln of e to the power of 2x. Now we can only have 2x on one side, which means we will have that ln y equals to 2x. And as a result, if we write x in terms of y, we will have that x equals to ln of y divided by 2. Alright, that's our inverse. Let's write it as our inverse. Good. Now in question B, we want to find out the derivative of our inverse. So we want to find out the derivative of our inverse, given that the derivative of our inverse is equal to 1 over the derivative with the input of the inverse. And it all sounds a bit complicated, so let's solve it the simple way first. How would we deal with a simple derivative? Well, we take our function, the inverse, and we differentiate it. So let's do it. Let's write our inverse, that x equals to 1 over 2 ln y. 1 over 2 ln y. Now we take the derivative of x with respect to y. Okay, if we take the derivative of x with respect to y, it means we take the derivative of this function, because x is a function of y, so regular derivative. Which means that the derivative that we're looking for, which we can write as f minus 1 of y, right, the inverse derivative, is equal to the derivative of this thing, and we have 1 over 2 times ln of y derivative. 1 over 2 is a constant in this product, so we keep it like that, times ln of y derivative with respect to y. Okay, if y is our variable of interest, and we know the derivative of ln x, remember the basic formula, ln x derivative is 1 over x. Well, in our case we have ln y derivative, but we're differentiating with respect to y, just like here we're differentiating with respect to x. So the result would be just 1 over y, which means that our derivative of the inverse is equal to 1 over 2 times 1 over y, and that's equal to 1 over 2y, and that's the answer. That's what we are looking for. Okay, that was the most common way of solving. I mean, it's just the direct application of derivatives, but let's solve using this formula that they ask. So 1 over f prime, and the input is the inverse. Well, we know the function, we know the original function, and first we have to calculate this thing, the derivative of the original function, so that eventually we'll plug in this input. So let's do it. Where is our original function? And let's solve it. Let's actually go to the right and solve it here so we can see everything. The original function is equal to e to the power of 2x. So let's go to the right and differentiate e to the power of 2x. F prime of x equals to e to the power of 2x derivative. And what is that? Well, e to the power x derivative equals to e to the power of x only, but e to the power of 2x derivative, well, that's a function of x, an expression of x, so it's like a star. We differentiate it, and that's e to the power of star times the derivative of our star. In our case, we have e to the power 2x times 2x derivative, the chain rule. So that's equal to e to the power 2x times 2. Alright, that's what we got. Now, how can we use this to solve our question? Well, if that's our derivative with respect to x, and we want to use this result into this formula down here in part B, how can we apply it? Well, we know what is the derivative with respect to x, but now instead of that derivative we're going to substitute the inverse of y. So we have to substitute this thing into x over here. Let me draw an arrow so we can see. Hopefully we can see. Let me zoom out over here. So I hope I can connect it. We'll plug in this all the way over here. So how would that look like? Let's see. We would have f derivative of the inverse, and the inverse is equal to, where did we find out the inverse? It was over here. The inverse is equal to ln of y over 2. So we'll substitute ln of y over 2 into x. So we will have, let me zoom in again so it's easier to follow. We will have the following. We will substitute our inverse into x. Okay, that's equal to 1 divided by 2 times e, and instead of x we substitute the inverse, because that's our input into the function. So 2 times the inverse times, yeah, and we times no, that's it, because that's the derivative. 1 divided by 2 times e to the power of 2 of x, so e to the power of 2 times the inverse. Okay, so we go on. Instead of f of minus 1 of y, we substitute our inverse that we calculated, so that's 1 divided by 2 times e to the power of 2 times the inverse is 1 over 2 ln y. Let's write it a different color. 1 over 2 ln y. 2 and 2 cancels out, so that's 1 over 2 times e to the power of ln of y. What does e and ln do? They cancel out. And what are we left with? E and ln cancels out, so it's 1 over 2y. This is the result by using this long formula. Let's go back to our basic formula of derivatives that we used. What was our final result? The same, 1 over 2y. So 2 ways, same answer. Hope this makes sense. In the next video we'll go through part C.